Hey there, math sleuths! It's Lexi back on the case of the vanishing rational numbers. Remember our first adventure where we uncovered what makes a number rational? Well, dust off those detective hats and grab your favorite snack because today we're diving deeper into the rabbit hole of rational number mysteries, complete with plot twists that would make Sherlock Holmes jealous. Don't worry, no trench coats or actual stakeouts required, just your brain power and maybe a sneaky calculator hidden in your detective toolkit. Let's roll. So, let's start with our first mystery. What makes a number rational anyway? Think of it like this. A rational number is like a really good friend. Why? Because it can always be expressed as a fraction. It's dependable, predictable, and always shows up as a, over b, where a and b are integers and b is never zero. It's like that friend who always texts you back, totally reliable. Now, here's where it gets interesting. Let me show you some numbers, and you tell me which ones are the good friends, rational numbers. Is 0.75 rational? Well, let's see. 0.75 can be written as 75/100ths, which simplifies to 3/4. Both 3 and 4 are integers, and 4 isn't 0, so yes! 0.75 is rational. It's like finding out your friend is even more awesome than you thought. This number's clearly playing by the rules. So yes, 0.75 is as rational as it gets. It's like finding out your quiet friend actually has a killer dance move hidden away. The number pi. Now pi is that friend who's, well, a little unpredictable. Pi equals 3.14159. And those digits keep going forever without any pattern. We can't write pi as a simple fraction, so it's irrational. Think of pi as that friend who always surprises you, never quite the same twice. It's the wild card who never shows up on time or in the same outfit twice. Pi is irrational through and through, the rebel of numbers. The number square root of 9. Square root of 9 equals 3, and 3 can be written as 3/1. Since both 3 and 1 are integers, and 1 is not equal to 0, the square root of 9 is rational. That's the drama-free friend you weren't expecting. Turns out this surprise is exactly what you hoped for. Rational, reliable, and ready to mingle. Now, let's see what happens when we convert fractions into decimals. For example, 3/4 turns into 0.75 by dividing 3 by 4. How do we know 0.75 is rational? Well, it terminates. The decimal stops. Just like a well-edited movie, no endless commercial breaks. Any decimal that either terminates or repeats is rational. It's like a song that either ends nicely or has a catchy chorus that repeats. Both are perfectly fine. When we look at a number line, the distance between any two numbers is always the absolute value of their difference. For example, walking from house 2 to house 5 is the absolute value of 2 minus 5, which equals to the absolute value of minus 3, which is 3 steps. It doesn't matter which direction you go. You're just counting the steps. Simple, right? Even detectives like to keep things straightforward sometimes. Ready for a quick fun trick? Let's convert 1/5 into a percent. First, turn it into a decimal by dividing 1 by 5, which equals 0.2, then multiply by 100 to get 20%. How do we know 0.2 is rational? Because it stops right there. Like a joke with a punchline that lands perfectly every time. Here are some numbers on the loose. Can you identify which ones are rational? 0.333. That's 1/3 in disguise. The square root of 16. That's 4 in a fancy outfit. 2.718281828. That's E. Euler's number. The mathematical constant, a bit of a rebel. Pause. Think for a moment. Here are the answers. 0.333 is rational because it repeats. The square root of 16 is rational because it equals 4. And E, Euler's number, is irrational because its decimal expansion never repeats or terminates. Here's how I remember rational numbers. Rational numbers can be written as ratios, fractions. And if you can write it as a fraction with integers on top and bottom, with the bottom not being 0, then you've got yourself a rational number. In day-to-day living, rational numbers are everywhere. When you buy something for $3.25, that's a rational number, 325/100ths. When you eat 3/4 of a pizza, that's rational. When you score 85% on a test, that's rational too, 85/100ths. So remember, fellow detectives, rational numbers are your dependable pals, expressible as fractions, decimals that end or repeat, and they always have their spot on the number line. Keep polishing those detective skills, and soon you'll be spotting rational numbers in every corner of your math adventures.